Cost-sensitive learning is a technique used in classification problems where making mistakes on different classes has different consequences. Standard machine learning methods try to minimize the total number of mistakes, treating all errors equally. Cost-sensitive learning aims to minimize the total cost of those mistakes. The key idea is to assign different costs to different types of misclassifications. For example, misclassifying a sick person as healthy might have a much higher cost than misclassifying a healthy person as sick. Here's how this is applied to various algorithms, without using formulas. 1. Decision trees. When building a decision tree, the algorithm chooses splits that best separate the data. In cost-sensitive decision trees, the algorithm considers not just how many data points are misclassified by a split, but also the cost of those misclassifications. It will prefer splits that reduce the overall cost, even if they might lead to slightly more total errors. 2. Support vector machines, SVMs. SVMs try to find a boundary that best separates the different classes. In cost-sensitive SVMs, the algorithm is adjusted to penalize mistakes on certain classes more heavily. This effectively pushes the boundary to better protect the class with the higher misclassification cost. 3. Neural networks. During training, neural networks adjust their internal parameters to reduce errors. In cost-sensitive neural networks, the algorithm is modified to give more importance to mistakes on certain classes. This is done by weighting the errors differently, so that mistakes on the more costly class have a greater impact on the learning process. 4. Ensemble methods, random forests, gradient boosting. These methods combine multiple simpler models. Cost-sensitive versions of these methods can be created in a few ways. The individual simpler models can be made cost-sensitive using the techniques described above, e.g., cost-sensitive decision trees. The process of combining the simpler models can be modified to give more weight to models that perform well on the more costly class. Cost-sensitive learning is particularly useful when dealing with imbalanced datasets, where one class has significantly fewer examples than the other. Problems where different misclassifications have very different real-world consequences. The goal is always to minimize the overall cost of errors, not just the number of errors.